Good morning friends. Today I will start 2.5 lecture number 13 question number 4, and question number 4 is expand each of the following using suitable identity. You see part 5th, because all the parts they are same. Minus 2x plus 5 minus 3z whole square. Here you check which identity you will use here. You see this identity a plus b plus c whole square. It is in the form of this. Clear? In place of a, minus 2x. In place of b, 5y. In place of c, minus 3z. So a plus b plus c whole square equal to a square plus b square plus c square plus 2ab plus 2bc plus 2c. Here in place of a, minus 2x plus 5y minus 3z whole square equal to a square. In place of a, minus 2x whole square. In place of b, 5y whole square. In place of c, minus 3z whole square plus 2ab plus 2a minus 2x. In place of b, 5y plus 2b. b means 5y, c means into minus 3z plus 2c. c means minus 3z into a means minus 2x. Then minus square always positive. 2 square 4 x square. 5 square 25 y square. Minus 3 square always positive. 3 square 9 z square. And here plus minus 2 to the 4, 5 is 20 xy. Here plus minus 2, 5 is 10 plus 10 into 3, 30 yz. Here plus minus plus 2, 3 is 6, 2 is 12 zx. Clear? And next question is 5th, factorize. I will take here second part. 2x square plus y square plus 8z square minus 2 root 2xy plus 4 root 2yz minus 8xz. So this is the expansion of in this form. It is clear? A square plus b square plus c square plus 2ab plus 2bc plus 2ca. First of all, you write this one in the form of this. A square in place, yes, 2x square. 2. This 2 is the square of root 2. Clear? So this one you can write root 2x whole square. Same y square. 8 root 8 whole square. Make the factor of 8. 2 into 2 into 2. Then the pair, this you can write 2 root 2z whole square. This one, it's clear or not? 2 root 2z whole square plus, you see very attentively here, if these three terms are there, plus 2ab plus 2bc plus 2ca. If two terms they are negative, you check which term are negative. Here this one and this one is negative. And what is common here? Here x is common, yes. Y not. Z not. Here x is common. So the term of x is negative here. You put here minus sign. Clear? Then in place of a, minus root 2x, in minus root 2x. In place of b, y. In place of c, 2 root 2z. So you put here in place this. Here it is complete. And then plus 2ab plus 2 in place of a, minus root 2x into b, y plus 2b. b means y. Then z, this one, c, and plus 2ca. 2c means this one, a means this one. So this a square plus b square plus c square plus 2b plus 2bc plus 2bc, this you can write a plus b plus c whole square. Similarly, this you can write a means minus root 2x plus b plus c b whole square, or this you can write 2 times. Similarly, a plus b whole square equal to a plus b into a plus b. Now question number 6 is write the following cube in expanded form. Yes, 3 upon 2 x plus 1 whole cube. So using this identity, a plus b whole cube, a cube plus b cube plus 3a square b plus 3ab square. Similarly, in place of a, 3 upon 2x, in place of b, 1. So a cube plus b cube plus 3a square b plus 3ab square. B means 1 square. Now 3 cube 27, 2 cube 8, x cube 1 cube 1, then 3 square 9, 3 ja 27, 2 square 4 x square, then 3 3 ja 9 upon 2 x 1 square 1, and then it's clear. Now fourth part, x minus 2 upon 3y whole cube. You use this identity, a minus b whole cube equal to a cube minus b cube minus 3a square b plus 3ab square. Clear? Then in place of a, x, in place of b, 2 upon 3y whole cube equal to a cube minus b cube minus 3a square x whole square into b, 2 upon 3y plus 3a means x, b square 2 upon 3y whole square, x cube minus 2 cube 8, 3 cube 27 y cube minus 3 cancel by 3, 2 x square y, then 2 square 3 same, x 2 square 4, 3 square 9 y square, 3 3 ja 9 cancel out, and x cube same, and here 4 upon 3 x y square. And then question number 7, evaluate the following using suitable identity. This 99 cube, this you can write 100 minus 1 cube, and you use this one identity here, you can calculate it. And second part, 102 whole cube equal to 100 plus 2 whole cube, you use this one identity. In place of a, 100, in place of b 2. Clear? You put here and get the answer. Thank you.